Today, được chưa? Nghe được rõ chưa? Okay. Good morning, my name is Han. Today I want to present about my lesson plan about how to teach the law of the conservation of mechanical energy. First, I suppose that my students in class at the medium level, and besides they had already know about the potential energy, kinetic energy, energy schools theories, and besides in the previous experiment they learn about the investigate the law, the free fall motions. And after this lecture, I want students can gain some equity skill like design the experiment, manipulate the apparatus to set up and execute the experiment, and finally discuss about limit station and maybe improve the experiment. So in the last part, I mentioned a situation that if we have an object fall freely from Z1 to Z2, and by theoretical ways that student can find the law of the conservation of mechanical energy, that the sum of kinetic energy and potential energy equal constant. And other way we can describe it by mg's z1 plus a half mb1 square equal mg's z2 plus a half mv2 square. So how to verify this law? So to elicit the problem, I want to mention a real situation that if I have a ball and when I drop it downwards and then it falls freely and hit to the ground and then bounce up. If we apply the law of conservation, so the ball can reach the initial positions. But let's see what is the real happen. Then I drop the ball and see that the ball cannot reach the initial position. So what happened? Is the law wrong, or what condition we need to notice when we want to apply this law? Okay, after that, I ask students how we can verify this law by experiment in context of free fall. So because in the previous experiment, student has already learned to experiment to investigate the free fall motion, so they can easily to think about the apparatus in a free fall experiment. That is vertical track with two gates, A and gate B, and both connected to the digital timer like this, and an objects here. And so now how to verify the law by this apparatus? I think too simply we can choose this is our origins potentials zeros, so we can see that the sum of initial kinetic energy and the initial potential energy equals zeros. So we can get the equations. Yes. So I think the simplest way students can think to verify the law by experiment is directly by measure the G2s and then measure the V2s. V2 is instantaneous velocity, but in this experiment we can determine it by L over delta T, with L is the length of the objects and delta T is the time which objects walk the vertex B. And then we assume that is in the equation and conclude about the law. And the table in this is But this is not my real expectations for them, so I asked them find another way to verify the law. So let's think about verify the law by by deducing the consequence. So I think that some students can think that if we choose these two equal a value A, for example, and then by apply the law, they can find the V choose and then find the delta T's. And after that, they just need to carry out the experiment to measure delta T and then compare the results and conclude about the law. And finally, I want to give students another way to verify this law by the razor. I have delta T over delta 2. T1 and T2 equal square root of Z choose pi over Z choose. I think it's pretty difficult for students, so I will give students the result, this razor, and ask them to prove this from the laws. And after that, I will divide the class into 3 groups, and each group will to carry out the experiment to verify the law in different ways. This is group 1, group 2, and group 3. And after that, they compare the results to each other and find the advantages and disadvantages of each way and find the best way to verify the law in the experiment. And now I will carry out the experiment follow the second way because I have already collected data by doing experiment. In the second way, if I choose Z2 equals 50 centimeter, so I can find the delta T by apply the law that is equal 0.06 second, and Z2 equals 60 centimeters, so that T equal. So now I will perform the experiment. Okay, so here's a vertical trace, and this photogate A with the electromagnet and the photogate B, and both connected to the digital timer. Because we want to measure the time the objects block the photogate B, so we select the mode B, and to measure the length of this object we can use ruler or caliper. And now I take it to the electric magnet, and I set it at the height is 50 centimeters. Okay, so I will do it again because it has some errors when I okay. It was 0. Sorry, I made some mistake here. It was 0.006. And 0.05, and now we will do with the other distance. I set it at 60 centimeters. Pushes. I'm sorry. Okay. and it equals 0.005. So after that, I can compare the two results and conclude about the laws.
Okay, so that's in time. Good.
Yes.
So can you deduct from the law to the consequences over there about the time the object will block the photogate in case the photogate is at a position of 50 centimeters from above?
I just...
Can you write a
Okay.
complete formulation on deduction?
If we said C2 equal 50 centimeters, so apply the laws. So we can find that V2 equal with okay, from this equation, so I can calculate the...
You should use the calculators and see the final result.
Do you choose? Is about second.
6.4. So it is 0.006. Second.
Yeah.
And if that's right, 0.6, what were the reasons? Because that is the predictions based on the theoretical. So the final result should be exactly as you can calculate it. And the real result you can get here is just about 0.6, and you have to explain it. That is my comment. And, and the first thing before I recommend is that the prediction is 0.6, 0.5 is it originated from somewhere. It's not really
because I
students believe that it is from the theory. So better next time you should really go from the theory, from the conclusions from the result of the theoretical derivation of that.
Yes.
Go into the theoretical consequences of the laws. And with exactly what you have calculated, and then you do the verification experiment, and you see it seems correct, but there's still some differences, and you have to explain. So don't just write out.
Because I want to ensure the time, so I don't write all the thing I want to say on the board.
Yeah, but that is the key thing.
Yeah, okay.
Which value of hate should you use to make your prediction more clearly when you act or hate? Which value should you use?
This one?
Yeah.
This is the value I
You use teaching and teaching. But my question is, which value should you use?
Okay, I think it's not too short or also not too long, because if I put the distance here, so I think that zero is much more bigger.
Arrow of measuring what quantity?
Dualities.
Measuring what? Arrow in measuring what variable?
Duality, I think that.
What?
Duality. Dualities. Yes.
Okay. Why is not more error when the distance you take shorter?
Because I think that the movement of the object is accelerated linear motion.
Yeah.
And the velocity we need to find this way is the average velocities, the instantaneous velocities.
Yeah.
So if okay, to sorry. What? Sorry. So to calculate the V's, the instantaneous velocity by the equation L over delta T, so we have to sorry, I
So let's say because delta T is not the moment.
yes. It is average.
We consider from the starting moment or initial moment. Delta T is a duration. The object passed through the photon gate.
Box about yes.
And we know that from the previous knowledge that is free fall. And then so we can consider the average velocity as instantaneous velocity at the moment in between. As you can plot a VT graph is linearized and you see something like that. But if you set for the a little bit closer, so the time delta T will be bigger or smaller compared to this position.
Yeah, but this is only theoretic thinking. You should try it. You should use the X value is 20 centimeter and then 80 centimeter.
Okay, I will try to.
Do it.
Okay.
No, not right. Do it.
Okay.
I mean the value of H
So 20 and 80.
4 times bigger. Yeah.
Okay.
And then the time must be 2 times.
0.009.
Yeah. And 80. And prediction is 0, 0, 0 here or 5 is okay.
Okay.
Yes. Don't need to write.
It is okay.
Yeah. That is enough.
Okay.
That is the value of experimentation. When our conclusion deduction is right, we must reject the value of the times, and we can solve. We can see this. It's okay. It's enough.
Yes.
Don't need right error or something.
Okay.
For practical experiment, that is demonstration.
Yeah.
It's enough.
Okay, so with this comment, you can also verify the law in influence places and
Yes.
also make different kind of predictions. Here there's already like three
way.
consequences, but now you can check, verify it quickly, even all the three.
Okay,
Keep
okay.
writing here. Yeah, that is yeah.
Third one,
The first one, okay.
This one. It's very clearly.
Because I have just to experiment with the first one is curve Z2 equal 80 centimeter and Z2 equal centimeter, and we measure that delta T is 0.04 and delta T equal 0.009, and so
Okay, well, no need to memorize. Okay, the next one.
okay.
Quickly.